Good morning, everyone. Today I have come up with a new topic from Chapter 1 Categories of Computers. Dear students, computers are available in different sizes and types. So, in this video, we are going to discuss the classification of computers on the basis of their sizes. We will also discuss about the computer languages. So, on the basis of size, we can classify computers into 5 groups: mobile computers, microcomputers, mini computers, mainframe computers, and supercomputers. Along with these types, video game console and embedded system are also sometimes part of types of computers on the basis of their classification. So, we will add them also here. Now, let's discuss about supercomputers. Supercomputers are the most fastest and powerful computers. They often occupy the whole room space. They can process trillions of instructions per second, and they are the costliest computers till date. These type of computers are used in government organizations where large calculations mathematical programs are executed per day, like research centers, weather forecasting, enemy codex, designing missiles, etc. Supercomputers were originally discovered for the applications related to the national security like nuclear weapons, etc. Today we have many computers like ETA-10, Cray series, Param 10,000, etc. Now coming on to mainframe computers. Mainframe computers are also big, powerful and expensive multi-user computers. They can also process bulk of data together at same time. But yes, they are definitely slower than the supercomputer and small in size. Mainframe computers are also used in government organizations like airlines, railways, etc. because of their talent of multi-utility. Now mini computers. Mini computers are larger than microcomputer but yes, smaller than the mainframe computer. They are typically of the size of refrigerator, so they take less space and hence they have less storage capacity. You can see in the picture the example of mini computer. Mini computer first appeared in year 1990 and when they got replaced by microcomputers soon because microcomputer size was smaller and can be used by anybody at home. So microcomputers are the best computer which you can say as per a common man's need. They are used at many places because they are less costly, size is small, and storage capacity is also reasonable. So supercomputers, then mainframe computers and mini computers and finally we led to the personal computers that is called microcomputer because they are very handy, small in size and can be used anywhere. But there are few limitations of microcomputer also which cannot be overlooked. Because of their small size, easy interface, anybody can use it. Devices like CD, DVD, pen drive, hard disk are used in them for storing the data. Now, mobile computers, the most common kind of computer used today. Each person today is having a smartphone, is handling a smartphone because of the small size. They are very portable. Laptops, tablets, palm tops, and PDAs, PMPs. These are the few examples of mobile computers. Video game console. A video game console is an electronic computer device that outputs a video signal or an image to display a video game that one or more people can play through some type of game controller. These may be home consoles, which are generally placed in a permanent location connected to a television, or display devices and controlled with a separate game controller as shown in the picture. They are handheld devices and include many inbuilt functions. PSP is also an example of video game controller console. and is very common among children these days. Embedded computers. An embedded system is a combination of computer hardware and software designed to perform a specific function within a larger system. Such systems are embedded in many electronic devices which are commonly used these days, such as your television, your speakers, telephones, cameras, washing machines, and refrigerators, microwaves, etc. Now, coming on to computer languages. Language is a medium of communication, and to communicate with computer we need some common languages. These languages are known as computer language. So a language that is understood by the computer is known as a computer language. So let's learn about the computer languages. We all talk with each other in a certain language, but imagine that if you are talking to someone who only understands Hindi and you only understand English, then communication will become difficult and you will need a translator or a guide between you and him. Same way, a computer is a machine that cannot understand your language and needs a translator. Computer only understands two states of switches, on and off, where on stands for 1 and off stands for 0. And this language of 0 and 1 is called binary language, and the numbers are called binary numbers. Based on this, we have various types of computer languages. We can categorize them as low level and high level language. Low level language can be further divided into a machine language and an assembly language. Now let's see what is machine language. Machine language is a language in which instructions are given in the form of zeros and ones. Machine languages are understood by the computer without any translator. But at the same time, it is very difficult for the programmers to write the programs in this language as it includes only zeros and ones. Assembly language. This is second generation programming language. Instead of using only numbers, it also uses English words called mnemonic codes like LD for loading the program, ADD for adding numbers, SUB for subtracting the numbers. So this language is little better than the machine language. Now, for converting a program written in assembly language, we need a translator, and that translator is known as assembler. Since assembly language is not directly understood by the computer, so hence a translator is required. Now, high level languages. High level languages are simple language that use English and mathematical symbols like plus, minus, multiply, divide, etc. for their program construction. Examples of such languages are Pascal, Fortran, C++, etc. There are some advantages of high level languages like understandability. Programmers can understand this language better as it is close to the English. Debugging is easier, that is, removing of error is easier because it is easily understood by the programmers. Portability is another important factor, which means that the program written in high level language can be carried from one computer to another. A program written at one computer can be executed on another computer, which was the biggest drawback in machine level language. Now, assembly language also needs, high level languages also need some translator to convert the program into machine language, and they are the compilers and interpreter. So, a program written in high level language is converted into machine language by the help of compilers and interpreters. Now, let's understand the difference between the compiler and the interpreter. A compiler and an interpreter, as stated before, is a software that is required for converting a high level language into a machine language. So when a program is made in a high level language, it is in English and is called a source code. The compiler compiles it, converts it into a machine language, that is zeros and ones. Now, as I stated before, that high level program can be executed on any machine, it's portable. That means this executable code, which is made ready by a compiler, can run on now different machine also. Now to understand this process, look at this figure. The copy of a source code which has been compiled is now given to another machine, and that machine has an interpreter. The interpreter executes that code according to the hardware of the machine on which it is to be executed, and hence the output is generated on a different machine as well. But the working of compiler and interpreter is different. A compiler compiles the entire code in one go, checks for the error, and gives the output immediately at one go, whereas the interpreter interprets line by line and generates the object code and then gives its error. So hence the interpreter becomes slower and compiler is faster. A source code must go through several steps before it becomes an executable code. In the first step, the source code is checked for any syntax error. After syntax error are traced out, the source file is passed through a compiler which first translates high-level language into an object code, that is a machine code not ready to be executed. A linker then links the object code with the pre-compiled library functions and thus create an executable code. This executable code is now loaded into the computer's memory for execution. This is how the complete compilation and interpretation process finishes up, and we are able to run the program and see the desired output on our screen. Now let's see few examples of the languages which are using compiler and interpreter or both. So the language which have only compiler, that is that they generate only compiled codes, are C++, C and Objective-C. And the languages which generate interpreted code are PHP, JavaScript, etc. And there are also some languages which generate both compiled and the interpreted code. The examples are Java, C#, VB.NET, Python, etc. The popularity of the hybrid languages is more in the industry because the code generated by these languages can run on any kind of operating system and on any kind of computer hardware. This reason of both compilation and interpretation make these languages more user-friendly and more desirable by the programmers. So I hope this part of the languages you must have understood and you must have liked the topic. And here I am ending up my topic, finishing up. But before I end, I would like to show you a small video about what is programming languages. By watching this video, I hope the concept of programming language and the needs of translator will be more clear. So all the best, children.
What exactly is a programming language? Programming languages are the tools we use to write instructions for computers to follow. But to answer this question further, let's start by picturing a computer. Computers are machines that take an input and give an output. They're especially good at repeating tasks and performing calculations. Even though there are different types of computers, like laptops, phones, and even the computer that powers the little screen on your microwave oven, at the end of the day, all computers understand a common language: binary. Binary is a programming language made only of ones and zeros. The ones and zeros represent the states of on and off in the billions of switches on a CPU chip. When combined, the on and off switches represent data and instructions for how to complete complicated tasks and calculations. In this way, a computer's native tongue is binary. But as humans, it's hard to comprehend those ones and zeros. At a glance, binary looks like nonsense to us. Programming languages allow us to translate the abstract ones and zeros into something humans can understand. Programming languages fall into two different classifications: low-level and high-level. The programming languages that are closer to machine code or binary are known as low-level languages. For example, assembly language is a low-level language that's pretty hard to read because it's still structured to write instructions like a machine thinks, but it's easier to understand than ones and zeros. Although difficult to write, low-level languages are fast and give the programmer precise control over how the computer will function. On the other hand, high-level languages like Java, Python, and C++ are closer to how humans communicate. They use words in their instructions that are close to the language we use in our everyday, making them easier to program in and maintain. The downside is that they take more time to translate into machine code for the computer. As computers have become more powerful, the difference in runtime between low-level and high-level languages is often only milliseconds, which means that high-level languages can be used in more scenarios. So for the most part, high-level languages do the trick, which is why almost all software engineering jobs hire people who can program in high-level languages. High and low-level programming languages each have their own philosophies, advantages, and use cases, but at the end of the day, all programming languages are just different ways of telling computers what to do. Programming languages are tools, and deciding which one you need to use is much like the process of picking any tool. A hammer is easy to use to drive nails and requires less skill than using a saw, but try using a hammer to cut down a tree. As you explore the world of programming, understanding which languages are good for which tasks will become more clear. While humans and computers may not speak the same native tongues, programming languages are like a bridge. They allow us to translate our thoughts into instructions a computer can understand. In this way, you can think of programmers as the ambassadors between humans and computers. So no matter which language you choose, welcome to your new role as a tech.
Not nice video. I hope you would have liked it. So thank you for watching. All the best, children.